Okay, I think we can get started. Others will just find us on the um we are also recording, so yeah, I think they'll be able to follow up with the recording. Um I hope I'm audible, not talking to myself, please. Thank you. All right. So hi everyone. Welcome to our seminar, second seminar of the year. Today we've been joined by Alfred, who is gonna give us a talk on the topic Beyond Swahili, designing inclusive AI for Bantu languages. In this talk, Alfred will outline, how these factors have. Sorry, let me just read a bit about the abstract. So, Swahili has become one of the most consistently represented African languages in modern AI benchmarks, uh, spanning machine translation, language modeling, multilingual evaluation suites, far exceeding the coverage of any other Bantu language. And this prominence reflects its scale, standardization, and regional reach. But it also exposes the structural challenges of building AI for Bantu languages. So, including rich morphology, pervasive code switching, and highly uneven data availability. So, in this talk, Alfred will outline how these factors have shaped Swahili's development within the contemporary AI systems, showing why direct transfer from dominant global languages often fails to capture Bantu linguistic structure. So, drawing on work in benchmarking, data creation, and cross-lingual modeling, he will illustrate how Swahili provides a technical viable bridge for Bantu languages in machine translation, representation learning, and also multilingual evaluation. An approach less tractable through non-Bantu pivots. So a bit about Alfred. Alfred's work spans lexical and morphological resources, question answering, audio corpora, pre-training data sets, multilingual common sense evaluation across 100 plus languages, LLM evaluation, prompt analysis, and culturally grounded synthetic data. So he's driven to build open community-centered NLP resources and create trustworthy, context-aware language technologies that strengthen education, governance, and accessibility across East Africa and the wider African landscape, linguistic landscape. Thank you very much, Alfred, for agreeing to give us a talk today one more time. I'll now hand it over to you to share your screen and proceed with the presentation. Welcome.
Thank you very much. Greetings, everyone. Good afternoon from your side. Good evening from my side. I hope you can all hear me. Thank you for having me. I'm a bit anxious, so if you hear a loud beating, it's my heart. I'm a bit nervous, but I hope today's talk, I will try to talk about designing inclusive AI for Bantu languages beyond that, more in detail around Swahili, which over the past few years, as in the abstract has already said, it has become most visible African Bantu languages in the modern AI systems, and it has appeared in benchmarks, in multilingual models, in translations, but also in evaluation suites. And on the surface, this is progress, and we agree with that. But when we look more closely, Swahili's success reveals a deeper technical question, and that is what happens when one language becomes the entry point for an entire family, a language family. And today, I hope that through this exploration in Swahili, how it how it has become a pivotal language in AI. And we can also see how this rapid progress, and we can break it down, and we can basically use that momentum to responsibly build AI models that will work across a larger Bantu language family. Before we get into the technical part, a bit about me. I would like to introduce myself. My name is Alfred Malengo Kondoro. I am from Tanzania. Currently, I'm pursuing my PhD in data science at the Hanyang University in South Korea. My research sits at the intersection of human-computer interaction and multilingual natural language processing, together with African technologies. My interest in this topic is very personal, as I am a Swahili and Jita native from the coast of Lake Victoria. But over the years, I've also been exposed to different experiences such as German, Turkish, Korean, but also using English in my academic and research works. So on a daily basis, I have been able to navigate multiple linguistic systems, not just socially, but also structurally. And living, working across these languages has made me start asking myself as I get into the research, how do multilingual AI systems behave when language is structured differently? Because through all of these languages, they are all, structured differently. And more importantly, what happens when the languages we care for about are not in these systems where these systems are basically designed for? And that question is the key motivation for my talk today. So I'll start my discussion around Swahili. And Swahili is spoken by an estimated of 100 to 200 million speakers, including both native and second language speakers across East and Central Africa. More importantly, Swahili functions as a regional lingua franca, enabling communication across diverse ethnic and linguistic communities that do not share a common first language across Tanzania, Rwanda, Burundi, Uganda, Kenya, and other parts of DRC Congo, moving to Zambia, Malawi, Mozambique, Comoros, Somalia, Ethiopia, and also South Sudan. And this this is also due to Swahili holding an official or working status in the major regional institutions, including the East African Community, but also the African Union. And we're seeing continued institutional expansion in recent years across countries such as Somalia, South Africa, Botswana, Namibia, Ethiopia, and South Sudan, which are either in the plans or have already introduced Swahili as a subject in their school systems. And also from a technological perspective, Swahili is not a niche language. It is a high impact regional language with growing education, government, and cross-border perspective and relevance, making it a very strategic entry point when thinking about multilingual AI for Africa. Now, if we zoom out and place Swahili within the broader Bantu language family, Swahili is one of more than 500 Bantu languages, which is a form of the major Niger-Congo branch language family. And these languages are spoken across the Central, Eastern, and Southern Africa, making Bantu one of the largest and most geographic expansive languages in the world. What makes this especially important for AI is that this language share a very deep structural characteristics, from noun class systems to strongly agglutinative morphology and complex verb extension systems. From a linguistic perspective, this is not a random collection of unrelated languages. It is a family of shared grammatical architecture. However, despite this shared structure and very large speaker base, AI representation across the Bantu languages remains highly uneven. Swahili has received disproportionate attention in datasets, benchmarks, and models development, um, which is uneven compared to other Bantu languages. And this imbalance raises another important question that motivates the rest of this talk, which is how do we tackle the AI imbalance across other languages using Swahili as a pivot? And one might ask, now we have already positioned Swahili within the Bantu family, why does it have a stronger digital advantage? And one of the major factors is the standardization and orthographic stability. Swahili has benefited from decades of sustained codification and relative unified spelling conventions and cross-national education's alignment. This reduces fragmentations in forms of complexity in the NLP systems. From an engineering perspective, this matters a lot when spelling, grammar conventions, and writing conventions are relatively stable across countries, and it becomes easier to collect data, build corpora, but also train models that generalize well. For example, projects such as the Uliza Llama and SMS or USSID conversional pipelines, which I was a part of as an author for the paper which is submitted to the PUI 2026, we show that Swahili can act as an interactional layer for AI systems, even in low bandwidth and feature phones environments. This means Swahili is not only present in research benchmarks, but it's also a socio-technical combination of standardizations in educational infrastructure and real-world deployment. On a deeper level, Swahili as an interactional layer allows regional deployment through shared linguistic interfaces. In practice, this means we can build from a single inference pipeline from either USSID or SMS gateways to APIs, and even the models use the same infrastructure across multiple countries. So instead of rebuilding separate systems, for every language and every deployment, we can create a shared input layer. This reduces the infrastructure duplication and minimizes system fragmentations. For example, this is the Luganda deployment, which can be adopted from Swahili, and this can also enable incremental multilingual extensions to other languages. Another important factor behind Swahili digital advantage is the institutional and governmental support. Swahili has been integrated for decades into the education systems, the media broadcasting, and the administrative communication, supported by the national language policies and leadership efforts, most notably of those of Mwalimu Julius Nyerere to promote its nationwide use in Tanzania, and the late Mzee Jomo Kenyatta in the same efforts in Kenya. And the same has been adopted into other countries. And this long-term adoption has generalized its substantial written corpora and enabled earlier digitalization compared to many other Bantu languages. So for a while, many African languages are now only entering into these digital spaces. Swahili has had much longer runway of standardized written usage, but also even into the speech usage in terms of data sets. But it has also enjoyed wide use in trade, media, and governance across East Africa, East and Central Africa, but also across the borders into West Africa, but also it has enjoyed regional acknowledgement such as from UNESCO, African Union, but world level agencies. Swahili's digital advantage is not only technical, but it is also institutional, as we have seen in the inclusion in the multilingual benchmark has been for a while as well. For example, in the 2019, in the XNLI benchmark, one of the first largest cross-lingual natural language inference evaluations included Swahili as one of the major languages, with other languages such as German, French, Danish, Spanish, in English, Russian, Chinese, and Arabic. And this inclusion is technical significant because XNLI was designed to evaluate cross-lingual sentence representations under zero-shot transfer settings, and models were trained on English NLI data and evaluated directly on other language without language-specific supervision. By being a part of XNLI, Swahili became embedded in the evaluation loop of nearly every major multilingual model, including MBET, XLMR, laser, and other subsequent transfer-based architectures. From a modeling perspective, this means that Swahili influenced multilingual embedding alignment objectives, but also it became a part of shared word vocabularies, and it was used to measure cross-lingual generalization performance. And at the point, you can say, like, you can coin it as benchmark gravity. Once a language enters and a widely adopted benchmark, it becomes structurally difficult to ignore, and model developers optimize it, report scores on it, treat it as a representative of its region. So Swahili's presence in the XNLI in 2019 positioned it as a de facto Bantu representative in the cross-lingual evaluation, and that early inclusion compounds over time, as we see into the next slides. As I've been speaking about benchmark gravity, benchmark and dataset gravity, Swahili appears across multiple machine translation and reasoning evaluations and dataset creations. For example, the Afro-MT, the MGSM Pro, the MMT Africa. This means Swahili is repeatedly used during pre-training evaluations and benchmarking cycles. From a systems perspective, this creates data gravity. Once a language appears in early benchmarks and datasets, it keeps getting used and reused in future work. And researchers select languages that already have evaluation datasets, have baseline results, and existing pipelines. So Swahili early inclusion creates a feedback loop. And this is the beginning of Swahili emergence as an African language in multilingual NLP. And this slide also shows how gravity compounds over time. So now we see extreme, we see MMT in East Africa, we see diversity in Swahili, and also even industry-facing benchmark comparison of Swahili in LLM performance. And this is a critical shift. Swahili is no longer just included as a normal language, but it's becoming a standard evaluation language. And when a language becomes standard in evaluation, it becomes embedded in training pipelines, benchmarking suites, models, release practices, and development decisions. In other words, Swahili is now a part of the default multilingual stack. But now, as we move from presence to performance, we can ask ourselves, what do the numbers actually tell us? First, in the terms of translation performance, Swahili to English consistently outperforms English to Swahili, and this is a very important signal. It tells us that multilingual models learn strong Swahili representations for understanding, but generating correct morphology still remains harder. And this asymmetry is exactly what we expect from a morphological rich language. And when we see the direct evidence that in terms of morphology, we see that word alignment improves dramatically when we move from word level to morpheme level. And this just shows how tokenization and morphological segmentations are not just pre-processing choices, but they fundamental change the multilingual model performance. And as we move to the transfer learning and the pivotal role of Swahili, we see that Swahili functions better as a pivot language in terms of machine translations compared to English, because of the morphological rich characteristics that it possesses in comparisons to English. And finally, transfer works, but only after adaptation. Swahili can enable transfer across Bantu languages, but it can only replace language-specific modeling and evaluation. So up to now, we have seen Swahili's strong presence and performance. So the natural assumption emerges that maybe the solution is simple. We just need to add more data. And this belief is very common in multilingual NLP. The data quantity assumption in terms of performance for African languages is often explained as a data scarcity problem. And the reasoning is very straightforward, that if we collect more data, the performance will improve. And this, in together with, if we need bigger data sets, for example, from English and French, we can just apply the same strategy and it can work to everywhere, which also is not the correct myth, because as you transfer from high resource language, most of the times models are expected to generalize automatically through multilingual embeddings. And in other words, the knowledge should just be transfer free. But the key message in all of this slide is that all of these assumptions need to be taken with a grain of salt, because in the evidence that I will show you, it is not just easy to add more data from Indo-European languages into Afro-Bantu languages because of the differences in multilingual embeddings. So as we start to see that the idea of just adding more data begins, as we begin to break it down, we will see that the Bantu languages are not simply smaller versions of English or French or the Indo-European languages. They are fundamentally, they have their own fundamental and linguistic structure, and which has their own class systems, agglutinative morphology, complex verb extensions, and highly productive derivation. For example, the word nilicheza, it contains the word the morpheme ni, which is for me, ni li, which is the past tense of was, and cheza is the lemma for play. So this means that the single word can encode a large amount of grammatical informations. And this also aligns with the morphological density, whereby this is the core problem of just adding more data, because most tokenization and embedding strategies designed around Indo-European languages they do fail for morphemes, because the Indo-European languages, the grammatical information is spread across multiple words, but in Bantu languages, that information is compressed into a single word. So when we scale without changing the representation of the strategies, we do not fix the problems. We simply scale the misalignment, and this can lead to many errors, as we'll see in the next slide. So now we slightly reach the uncomfortable conclusion that if English and French were the main bridge languages in multilingual AI, why do we still see such gaps for Bantu languages? And First reason is the typological mismatch. When we transfer languages from the Indo-European languages to Bantu languages, the introduction of structure misalignment is because of the morphological differences between the Indo-European languages to the Afro-Bantu languages. And even when the translations are tried to put on the same scale, the representations are often misaligned. And Indo-European languages have the tendency to spread grammatical information across multiple tokens in comparison to the Bantu languages, as I explained before. And through these compressions versus expansion, there is a mismatch when the transfer is fundamentally across a large amount of data, which can lead to the third point, which is superficial transfer gains, because benchmarks improve through training, but when you come to test them in real life systems, they may not give the robustness that we observed during the training. And this gap is what we'll also see in the next slide. Getting more in depth now, we see that another failure mode is the machine translation hallucination. And this is especially common when translating from the high Indo-European languages into the morphological rich African languages. So for example, we note in the sentence, the children are playing in the house. It's typical hallucinated translation is watoto anacheza ndani ya nyumba. Although this sentence sounds fluent, it's naturally wrong because there is a noun class which is broken for wa, which it is an hallucinated machine translation. And you might ask yourself, why would the model think this is correct? A neural machine translation model are usually trained to maximize the probability of the next token given the previous token. And they're not explicitly trained to enforce grammatical agreement. So if a sentence sounds fluent, the model receives a high reward. And multilingual training data is usually dominated by Indo-European languages. In those languages, agreement is often optional or weakly expressed compared to Bantu noun class systems. So if the model learns that agreement is soft constraint, not a strict one, it's rarely taken into consideration. So swapping a in this sentence to wa barely changes the probability of the sentence. So in the model's perspective, both sequences look plausible. And based due to the decoder bias, the decoder will has a huge preference of globally fluent sentences over enforcing long-range agreement constraints. It will choose fluency over correctness, and this is how and why these hallucinations come to happen. Moving on to another layer deeper is that even if the model does not hallucinate, another structural issue is that multilingual tokenizers allocate vocabulary based on global frequency. So that means language with massive corpora such as English receive cleaner, larger, and more stable subword units. But morphological rich Bantu languages are fragmented into more pieces. So for example, a sentence such as I love my mother is split into 4 tokens, but if you translate it into Swahili is ninampenda mama yangu, which is 7 tokens. And in Luya, I will not be able to pronounce that. I got help to create the sentence, is also translated into 7 tokens. So you might ask yourself, so what just happened here? The same semantic content now occupies nearly double the token length. And this matters because transformer models have a fixed context windows and fixed attention budgets together with a fixed embedding capacity. So when a sentence is broken into more sentences, attention must be distributed across all of these units. And each subword receives less representational capacity and dependence becomes longer range. So representation quality degrades, and not because the language is harder, but because the tokenizer was optimized for a different typology. And this is what I mean when I say representational collapse. So low resource and morphological dense languages end up producing longer sequences and dilute attention in fragmented meaning and in 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 comparison to Indo-European languages. So again, it is not the issue is not only on adding more data, but also in the architectural alignment. So up to this point, we have been seeing how Indo-European languages are a weak bridge for Bantu languages. So a natural question will be if English or any other Indo-European language is a weak pivot, why does Swahili work better? So my answer will be based on structural compatibility. One, Swahili has the almost equal noun class agreement comparable to English, but also its morphological type. English is more analytic compared to the strongly agglutinative nature of Swahili, which is comparison to the other Bantu languages. The verb structure, English has a tendency to split its information across words, but Swahili is a prefix, allows prefixing and morphemes to be added to a word to encode its meaning. And in the subject agreement, English is word dependent in comparison to Swahili, and this happens for the subject and also for the object. In terms of the word formation, Swahili is more into morphemes, word formations, compared to English, which is intended for mostly in isolated words. And as we move from language intuition to model behavior, we see that these linguistic properties directly influence how multilingual tokenizers and embeddings and decoders allocate capacity during training. For sub-word tokenization, English typically produces fewer subword splits compared to Swahili, which is more identical to other Bantu languages. English sequences are usually shorter compared to Swahili, which are similar to other Bantu languages. The morphological supervision in English is very weak compared to Swahili. The cross-lingual embedding similarity, which influences the transfer learning behavior and the decoder training for the generations, are distant from Bantu languages, meaning that the attention as well is fewer in English because its tokens are smaller compared to Swahili, which is more similar to other Bantu languages. So training on Swahili exposes models to not only longer sequences, but richer morphology and agreement dependencies, improving transfer efficiencies to structurally similar Bantu words. So now I want to make this discussion more concrete with a real case study. This work I was fortunate to be a part of is the AFRI MMTEA, a multi-domain machine translation for the low resource in East African languages. The problem that we were facing is that in East Africa, the picture of multilingual on lingual NLP has been faced with huge gaps, and until previous to this paper, there were no benchmarks which were covering languages in East Africa to more than 20 East African languages, and many Kenyan and Tanzanian languages had no prior digital machine translation resources at all. So the gap was very clear that there was no large-scale, regional-focused, multilingual machine translation benchmark for East Africa, and there was no systematic study comparing English versus Swahili as pivot languages. And our work has two main questions. Can regional focus pre-training outperform global multilingual models? But also, can Swahili function as an effective pivot language for East African machine translation? In this work, we introduce our dataset and our benchmark, which is the first large-scale multi-domain machine translation dataset for East Africa, covering 53 languages, having more than 700,000 parallel sentence pairs. And this work expanded the machine translation coverage with 23 new Kenyan and Tanzanian ethnic languages, including languages that had no prior digital NLP experience, endangered languages, but also close to extinct languages. We fine-tune Gemma 3, 270 million tokens, and Gemma 3, 1 billion tokens to create Safari 270 million tokens and Safari 1 billion tokens, achieving consistent improvements over strong multilingual baselines. And importantly, what we found is that, first of all, we compared regional fine-tuning versus the Bayes multilingual models, and Bayes models typically scored below 20 in the CHRF metric, but the Safari and the both Safari models had a better performance of from 30 to 55 CHRF metrics. And when comparing downstream transfer, machine translations between Swahili to English and English to Swahili, we still see the symmetry that Swahili still outperforms Swahili to English transfer still outperforms English to Swahili transfer. And when we evaluate the downstream transfer to the local languages, we still see that Swahili outperforms English to local. And this is the key takeaway, that Swahili works even better as a pivot language. So what does this imply? Across all 53 languages, Swahili had a stronger transfer in terms of representations compared to English. And this encoder transfer efficiency helped us to compare and see how regional fine-tuning can improve lexical adequacy, morphological agreement, but also translation stability. And we were able to see large gains from low Swahili to low resource Bantu languages compared to English to low resource Bantu languages, and other languages that had limited English to the target languages paralleled opera. But also the scaling between 1 billion tokens to 270 million tokens across most languages pairs enabled us to see that performance scales with regional data exposure, showing us that capacity effectively utilized when training distribution matching with the target languages. So finally, apart from just seeing that Swahili was a better pivot languages, we also learned how to use the transfer and pivot languages responsibly. So one of the things was performance on the pivot languages must not only be used as a proxy for downstream languages. There should be per language evaluations after transfer. We should measure the degradation relative to the pivot language performance, but also reports on the zero shots and the fine-tuned performance gaps should also be included beyond the pivot language transfer and the downstream tasks. Another thing is that each language requires its own evaluation artifacts. So after the machine transfer, it's important to build language-specific test sets, error taxonomies, and evaluation metrics. This will include checks of agreement errors, morphological generation, and semantic adequacy. And the use of pivot for initializations. The use of the pivot language should be as an initialization point, but not a final deployment. So the use of the pivot language pre-training, it should be there for parameter initialization, data bootstrapping, and transfer learning. But it should then be followed with targeted data collections and language-specific fine-tuning. And finally, it's very important to still have a human in the loop for validation. So this includes either having a native speaker to do linguistic validations and iterative error analysis. And we can use that human feedback to guide dataset expansions, model refinement, but also the evaluations updates. Finally, my call to action is we should invest more in Swahili as a regional pivot language, moving from the Indo-European languages. And this can be done by prioritizing Swahili as a pre-training corpora, multilingual benchmark, but also in the fine-tuning of workflows, as we've seen in the evidence that the machine translation from Swahili to local languages outperforms English to the local languages. And building on top of that is building more on regional benchmarks and shared tasks. So we need to support more African-led research infrastructures, such as the current Masakane initiatives, the Native Research Group. But I would also ask to shine a light on a workshop that I'm co-chairing for this Sky 2026 on AI across AI across cultures, where we're trying to see how we can use the sources that we have to improve the environments or to improve the systems that we have in our day-to-day lives. And another workshops that I'm also a part of is the Understanding Machine Translation in Africa, which it's under review for the Deep Learning in Daba for the 2026, where we're trying to see all of these implications that we've just seen in the challenges in the machine translations. But also the final thing I spoke in the beginning, I wanted to challenge Millicent, was having Indaba Swahili, where every researchers from all countries can come and talk about the challenges or how Swahili has been a pivotal languages in their communities. I would like to finish by saying Swahili is powerful not because it replaces Bantu languages, but because it can help us build AI that finally it can build respect for those Bantu languages. Thank you very much.
Thank you very much, Alfred. That was quite insightful talk, excellent work. We truly appreciate the presentation. Do we have questions for Alfred? Thank you very much, Alfred. This was amazing and super insightful about our high resource language here in Africa, Swahili.
Yeah.
Cool. Mark, do you want to unmute and ask your question so that I don't read it? Just Mark, please feel free to unmute and ask the question.
Yeah, kindly confirm I'm audible.
Yes, you are.
Yes, you are.
Wow, thank you so much. Super insightful session, Alfred. So my question, I had sent it on the chat section, but just wanted some insights from you. Like there's a project that I'm working on, and I've tried different approaches and I've tried doing a lot of experiments here and there. So it's like a full duplex Kikuyu voice chatbot, like ChatGPT voice or Gemini Live, the voice chatbot. And just to give you one caveat is that in low resource, for instance, Kikuyu per se, most of the words, for instance, if I'm to say a word like area and iria, it's the same word. It's spelled the same, but it has entirely different meanings depending on the tone and the stress and also the vowel length applied to them. So when I say iria and iria, so iria is there and iria is milk. So you see, there are two different words. But in case I want to build like a full duplex working model, I need to make sure that my model understands or has that capability of when it's responding, it gives that specific word in terms of the tone of or the stress of that specific word. So you've mentioned something I've noted on regards to more data. I've been trying to look for data and I've tried to work with data here like the Africa Next Voices, and also there's this data set that was released this recently for TTS by the Waxal dataset. So I've tried to find ways on how to handle that, but possibly you'd share more insights. You said something to do with more data that is a myth. More data in NLP is a myth. So how would possibly I handle that, or some insights on how I can handle that? Yeah.
Okay, thank you very much. Thank you very much for your question. So if I'm getting your question right, is you're having trouble to there are some words that have similar meanings, but they kind of like have they have different meanings, but they have similar pronunciations in building LLM to TTS. So what I would say to that is I have also faced a similar problem in Swahili when we're trying to develop TTS, and that's actually ties back to one of my responsible use principles for pivot languages is maintenance of human in the loop. It's still hard at the moment, I understand, to collect data or crowdsourced data, but having a human in the loop to check or integrate to review if the data or whatever system is collected or whatever data is collected is actual the intention. I mean, whatever word is written is the actual intention might help in that situation. But currently, when you're trying to, especially trying to add more data from a high resource language, it's extremely hard, as you're saying, because meanings can be different. But I would say when you're using Bantu languages, it can be a bit more similar. I don't know if that answers your question.
Oh, yeah, but I didn't get that part on more data. Have you said like when I add more data, it will be helpful or it will be a bit more challenging? It's better off to just have a human in the loop, and then after that, what else? After they verify this and that, I don't know whether I got that point. Kindly, if you can.
No problem. So my point of the myth of more data is we instead of focusing on having a lot of data, we should focus on having high quality data. So in your perspective, instead of having let's say I think if my memory serves me right, the word is area. So instead of just having a lot of areas, we can have data concerning area in different perspective and having a human in the loop where the human in the loop can cross-check if all of those scenarios have been configured and that they have actually been addressed in the dataset in comparison than just having a lot of areas in the dataset which some of them do not address the scenarios that you want to address in the data set. I don't know if that is that answers your question.
Yeah, that answers my question. Yeah, that answers my question. But just a follow-up. Apologies.
No problem.
Yeah, just a follow-up. You said having a human in the loop to check all those words, and but I believe we have a lot of words. Possibly, I don't know that it will verify all the generations that will come from the model. Like try to ask all possible questions, because it's not only area that is one of the terms. It's just one of the terms, but we have a lot of terms or a lot of words which are kind of spelled the same but have different meanings. So are you like suggesting possibly have a human in the loop who will verify all possible cases or all possible words that might be generated from or might come from the model?
I'm suggesting we can have human in the loop, and then, for example, like what Masakane news dataset had is active learning. So we can combine the both of them and just have human in the loop and active learning. So active learning can learn from what the manual validation is doing, and we can work with that as well. I think the human in the loop is quite important for the next phase on validations, because that sets the gold standard. So I think that's quite unescapable for now.
Okay, thank you.
Yes.
Do we have any other question for Alfred?
Yes, Millicent.
Yes, Philomena.
Okay. Thank you, Millicent. First of all, great work. I really appreciate this presentation, and congrats for the work. I just have some questions about the paper that you recently published, the FPMMTEA. So the first question is the data that you collected free available, under what kind of license? Because this, I think during the slides I didn't pay attention about that. And then what domains are you having on this data set? Do you have like one specific domain, or like the combinations of diversity on the data set? And you also, the third question is you choose the KEMA model. There was a reason for that selection. If you have, can you explain why? And finally, did you do any narration studies? Like, for example, you focus on English to Swahili, English to local languages. But for example, in Africa, we have other regions, right? So like Portuguese speaking, French speaking. So do you think that these results that you have can be generalized to these other regions? Because I'm asking this question because in my own case, I found that in some cases, multilingual fine-tuning from this kind of multilingual models that can lead, for example, to improve of machine translation results, but in other cases is not true. So using like a general model that has been trained like a multilingual setting, not the African centric, sometimes can be even better than using those African model. So this is my own case, and I would like to see in your case if you experience something like that. Thank you.
Thank you very much for your question. So the first part you ask what is the data available online? So yes, the data is available. The paper is currently just published, so we're waiting for the DOI and everything, but I can share with you the data set. It's available on GitHub, and the sources that we used existing corpora, We used digitized or printed materials. We used summaries from dictionaries, glossaries. We also used poetry. We used the Bible as well, and because it was one of the most translated digitalized informations across multiple languages. So it was not really based on a certain field, but more on the available information and how we can transfer that information and track that information across multiple languages. And why we chose Gamma 3 is one, we wanted to test the transfer, not brute force the scaling. So it's very large proprietary models can mask transfer problems because of the sheer scale compensates for weak linguistic representation. So we tried to make sure that if improvements appears at 270 m to 1 billion parameters, it will show it shows gains come from data and linguistic alignment, not model size. And also we tried to make sure that the open weights also tracks to the reproducibility and African research accessibility because of the availability of the gammas. But also we tried to make sure that we had clean multilingual baseline for controlled comparison. And to answer your final question, you asked me, is it possible for the Portuguese speaking community, African speaking communities? So we are yet to go into the code switched versions of the language. We have not yet reached there, but I still believe that the Swahili or Bantu languages, even if code switched, excuse me, still have the same morpheme and morphological structure. So I believe it might still work, but we need to do some experimentations on that. I hope that answers. I hope I didn't miss any of your questions.
Thank you.
Yes. Yeah. And so we are like exactly 4 p.m. I wonder, Samuel, you want to ask a question? And then Mark,
Yeah.
but every other person, please feel free to drop. But if you find the conversation exciting, please stay. But at this point, feel free to drop off. Thank you. Sam.
Yeah, mine is a brief one, and I guess I'll preempt. I think maybe there's no clear-cut answer to it, but let me hear your thoughts on this because you've alluded a lot to the human in the loop component, which is quite critical. But then there's a challenge of it's quite expensive and slow, right? Is there like a sweet optimization spot for this that will allow there to be, because sometimes you want to train this and validate this quickly, right? Is there like a balance in terms of don't call it the effort, but something to that effect, like you're having human in the loop a certain proportion of the work, not fully, but yet you still need human in the loop because of being able to validate this and the cultural aspect to it and all and all. So I don't know whether your thoughts on that.
Yes, I will use the same, I think the same method also, Mark. I explained to Mark in the beginning that one of the methods I saw was in the Masakane News paper, dataset paper, is we did manual validation for a certain part, and then using those gold standard manual representations, they were used for training models to validate the rest of the data. So that was just one. I believe there was another one, but I'm not really, my memory doesn't serve me right at the moment, where we can use human in the loop for a few sentences and then use those gold standards to train the manual to the model to validate the rest of the data set.
Okay. Cool.
But I would also pose another question back to you, Samuel.
Okay.
Do you still believe in the model validations compared to the human ones, although it saves the effort?
It's a challenge because sometimes you want to move quickly, well, for obvious reasons, but then clearly the human, though we also claim the human, depending on the human you pick, may have different levels of competencies. But so it's still a huge advantage to have the human in the loop. It's just a question of the sweet spot. How do you balance these two, like the model validation, the human in the loop component? Yeah. So yes, I still believe in the usefulness of us as humans in this. It's just a question of how do you get that sweet spot because of the cost and also the effectiveness in terms of speed and all.
Okay. Okay, thank you. I agree with that as well.
Mark, do you want to go next?
Yeah, so mine is actually just a follow-up on regards to the data set.
Yeah.
The one that you're using, you had how many like records, or just to create some context, I recently did a fine-tuning of the translation GEMA model with TransGEMA 12B, and it was for Kikuyu, and for the feedback in terms of the scores, the blue score, the zero shot was like 2.29, and then after doing the fine tuning, it got a 19.61 blue score of English to Kikuyu. So, but this time I used around 30,000 English Kikuyu pairs that I received from one of the dataset I received in our research lab here in school. So I just wanted to do the dataset that you have here, because I saw the final version had about that 3 point something. I don't know. I'm not sure whether that is the one that you'd shared in terms of the performance after you did the fine tuning of the GEMA model. So just wanted to know how many records did you have for the translation? That is when you're fine tuning the GEMA model. And which one would be the optimal one, possibly, or I don't know whether.
For the metrics, currently they're not the ones that I just presented were okay. These were for all language pairs. But if my memory serves me right, you're asking for Kikuyu, right?
No. I'm saying for our case we did for Kikuyu, just wanted to know how many pairs. I guess I missed this slide. I think it's 714 parallel sentence pairs, as I can see here. So I guess I might have missed this slide. That is what I just wanted to confirm. So that means that it performed better because it had, I don't know, more data. And in case I have more data, it would perform better on my end for the Kikuyu one. I'm just trying, that confusion of the data.
But also, it was from English to Kikuyu, right?
Yeah.
Okay. And sorry, can you remind me of your parameters? What were your parameters in the experimentation?
So what we had in terms of the parameters for the model, like we were using the Translate GEMA 12B, and for the zero shot, it's scored 2.29 blue score in terms of the blue score, and then after fine tuning, we had about 19.61. It was 19.61 for the blue score. So should I like explain how we did it? But I see we are kind of far much past time. Or do you want me to explain how we did it in terms of, or we can further the conversation possibly after this?
Okay, we can further the conversation possibly after this, because I need also to cross-check for what we did on our side. Then we can have that comparison chat and see how you can improve your scores as well.
Yeah, sure.
Yeah, I'll be open to that. Maybe
I
can.
All right, thank you very much. I can actually connect you with Mark, Alfred. Yeah,
Yes.
I'll share his details. And Mark, I can connect you with Alfred as well. Thanks very much for today, Alfred. This was quite exciting. We went over time. This was a great conversation, and we truly appreciate your time. Everyone who stayed, thank you, and we'll keep you posted on what's coming up next for the next seminar. Thank you.
Thank you very much.
Yeah.